What is the Roblox rendering pipeline and how does it work? Imagine your game world coming to life with every movement and change happening smoothly on your screen. That magic is thanks to the Roblox rendering pipeline. It's a process that turns all the 3D models, textures, lights, and camera angles into the images you see when you play. Every frame, which is up to 60 times in a second, the pipeline works behind the scenes to create those crisp visuals. Understanding how this pipeline functions can help you make your game run better and look more polished. It all starts with your game's building blocks, models, textures, lights, and the camera. These elements define what your game looks like and how players see it. The rendering pipeline takes this information and processes it step by step. Think of it as a factory with different stations, each handling a specific part of creating the final image. This modular setup helps Roblox manage complex scenes efficiently and apply improvements at each step. The first stage is scene preparation. Here, Roblox checks which objects are visible to the camera and which have changed since the last frame. For example, if a player moves a part or turns on a light, the system marks those objects for updates. This way, it only spends time on what really needs to be redrawn, saving resources. Next comes geometry processing, where the positions, shapes, and orientations of all visible objects are calculated. This involves transforming objects from their local space into a shared space relative to the camera, and then projecting them onto a flat 2D surface. These transformations use mathematical tools called matrices, which help position everything correctly on your screen. Once the objects are in screen space, the pipeline moves to rasterization. This is where the 3D shapes are converted into pixels. The edges of triangles, which are the basic units of 3D models, are filled with color. During this process, color, textures, and lighting at each corner blend smoothly across the surface, creating realistic surfaces and gradients. After rasterization, the next step is shading and lighting. This stage determines the final color of each pixel by applying lighting effects. Roblox supports different lighting models, including simple lighting and more advanced options like physics-based rendering, which makes materials look more realistic by simulating how light interacts with them. Shadows, reflections, and transparency are also calculated here, depending on your graphics settings and device power. Sometimes, visual effects like glow or motion blur are added after the main rendering. These post-processing effects can make your game look more lively but might slow down performance on weaker devices. To keep your game running smoothly, you can reduce the number of objects on screen by hiding those outside the camera view or using simpler models for distant objects. Optimizing your models by keeping polygons low and balancing lighting effects can also help. Remember, effects like bloom or motion blur look great but can tax the system, so making them optional or adjustable can improve gameplay. Roblox provides tools to monitor how well your game performs. Use these to spot bottlenecks and make adjustments. By understanding each part of the rendering pipeline, you can build games that look good and run smoothly on many devices. Whether you are just starting out or creating complex experiences, knowing how the pipeline works helps you make smarter choices to improve game performance, optimize gameplay, and give players a better Roblox experience.